Assalamualaikum and hi, my name is Nur Ain Najwa binti Edi Mohamad. My metric number is AA191816. In this video, my friend Aliya Nazeera and I will explain the solution of application of differential equation. In this video, there are two cases that related to murder and water leak out from the vertical cylinder. Alright, we start with the introduction. So, application of differential equation are used in our daily life. For example, we use application of differential equation to solve the thermodynamic, to calculate the population growth of bacteria, and also to solve decay problem. In next video, I will explain the solution of P3 and Aliya Nazeera will continue with question N2. Alright, now I will explain the filler table of question P3. So basically, in filler table, we have 4 parts, which is fact, idea, learning issue, and resource needed. So from this question, the first fact that we get is the volume of water leak out from this vertical cylinder is proportional to the square root volume of water remaining. The second fact is the initial volume of water is 200 liters and the time is 0. And the last is we get that 20 liters water was leaked out during the first day. So from the fact, we also get the idea that help us to solve the problem. So the first ideas that we get from the question is the water leak out is proportional to the square root of water remaining. So we can get the equation from that, which is dV per dt is proportional to square root v. Next, the ideas that we get from the question is since in the question state the initial volume of water is 200 liters and the time is 0, so we can use that information to find the value of K. And last, the ideas is the remaining water during the first day is 180 liters. Since during the first day, the water was leaked 20 liters. So the remaining water on the next day is 180 liters. Okay, next is learning issue. So the first learning issue is how to integrate equation from the question. Since it states the volume of water leaked out is proportional to the water to the square root of volume water remaining. Next one is how to find the volume of water after 4 days. Last learning issues is how to find when will the tank will be half empty. And the last is resource needed. So we have find a few reference, which is we get from library UTHM and also the internet to solve the problem of question. Okay, so next is problem background. We have identified 4 main problems from this question. So the first one is amount of water leaked out is proportional to the square root of water remaining. The second one is when will the tank will be half empty. And the third one is how much the volume of water will be there after 4 days. And the fourth one is the water was leaked out 20 liters during the first day. So from these 4 problems, we need to use all the information that we get from the question to solve this question. Right now, I will share with you guys the solution of this activity. So the first step we need to do is we need to list out all the information that given in the question so that we can solve this problem. So the first one, it says the initial volume of water is 200 liters, and during the first day, 20 liters of water was leaked out from the vertical cylinder. So we need to make a table. Okay, since it says the initial volume of water is 200 liters, so 200 liters, the time the water was leaked out 20 liters. So on the next day, the volume of water remaining is 180 liters, which is time is 1. So we look at the question. So the question says find when the tank will be half empty. So we need to find time. What time the tank will be empty? So the initial volume of water is 200. So if the water will be half, the volume of water is 100. And next question is how much the water will be there after 4 days. So after 4 days, how much the volume left? After we list out all the information that we need in the question, we need to solve this. We can use the formula that we do to solve this question. But this question is different because it already says that water leak out from the vertical cylinder tank is proportional to the square root of water remaining. So for this question, the equation is dV over dt is proportional to slit v. Alright, so to solve this, we need to change proportional to equals, where we need to add k in this equation. So dV equal to dt is equal to k slit v.
boundary condition 1 into equation 2. Right, so the first boundary condition is 200, p is 200 and p is 0. So when the value of c which is 20 square root of 2, we need to substitute boundary condition 2 to find the value of k. So, okay, after we get the value of c, we need to find the value of k. So we need to use boundary condition 2, which is this one. Boundary condition 2. So k is equal to negative 1.4514. Okay, so after we find the value of c and the value of k, we can solve the equation. So the first question is saying, what times will the 10 will be half? So when 3 is equal to 100, t is equal we need to find and p is 5.707. Alright, so when we run off, it will be 6. So the answer for question A is 6 days. Alright, so next is question B. We need to find the amount of water after 4 days. So when B is equal to 4 and P is equal to 4. So and V is equal to 126.32 liters. The volume of water after 4 days is 126.32 liters. So the conclusion of this question, we get the answer for question A is 6 days. And the second question, the answer is 126.32 liters. Alright, so that's all the solution for question case study page.
Right, next is result and discussion. So in the solution, I have explained the calculation to solve this question. So the result is the amount of water remaining after 4 days is 126.32 liters, and the water will be half empty after 6 days. So from this question, we can conclude that student must know how to integrate the first equation by using separable method, and student should use all the information given inside the equation to solve this question.
Hi, my name is Aliya Jusoh. For my part, I will solve the question for case study M2. Firstly, I will briefly introduce about the case study. In this case study, a murder has happened. The dead body was first found at 4:30 am and its temperature was 88 degrees Fahrenheit. After 2 hours, the temperature became 85.8 degrees Fahrenheit. So for this question, Newton's law of cooling was used to make an equation. Then the equation was used to solve the time of murder and to find the murderer of the crime. For filler table, I will explain about the fact, idea, learning issues and resources needed. So first, for the facts, from the question, it states that it was a dark and stormy night and the detectives are called to the scene of the murder. And the most likely suspects are
the wife, the butler, and the business partner.
And the wife claims to have spent the entire evening at the theatre across the town. She was seen leaving there at
10:30 p.m. and returned home
at 11 p.m, going straight up to her room. And her return was verified. For the business partner claims that to have spent the evening working papers at the office. His wife and the household staff verified
that he returned home at 10:30 p.m.
And then lastly, the butler was
On his nights off, he claims,
been at the local pub until 10 p.m. The butler returned to his quarters above the carriage house at 10:05 p.m. and did not leave after that. This was also verified by other servants. And the detective Holmes arrived at the scene at 4:30 a.m. Temperature of the body was found to be 88 degrees Fahrenheit, and the temperature in the study room was 76 degrees Fahrenheit. After 2 hours of finding the body, the temperature became 85.8 degrees Fahrenheit. That is for the facts. And for
the ideas.
There are several ideas that I put in, which is the body was found at 4:30 a.m. and the temperature was 88 degree Fahrenheit, and after 2 hours it became 85.8 degree Fahrenheit. The temperature of the surrounding, which is in the study room, was 76 degree Fahrenheit. And Newton's law can be used to make a cooling equation, and the equation was used to find the value A and the value of K. And then he used the last updated equation to find the time of the murder and to reveal the murderer. The learning issues that we can get from the case study are how to solve using Newton's law of cooling in crime scene questions. And the second one is how to create the Newton's law cooling equation. And then how to find the value of A. And the last one is when was the murder happen and who was the murderer. For this case study, there are also kind of resources that I used, which is first is from the internet, and the second resources that I used was from the library of UTHM. The problem background for this case study, there was a murder that happened and the detectives were being called to the crime scene. The dead body was found at 4:30 a.m. in the study room, and its temperature was 80 degree Fahrenheit at that time, and after 2 hours it became 85.8 degree Fahrenheit. Furthermore, the wife,
The butler and the business partner that were called as the suspects of the crime have their own strong motive and alibi that tells their whereabouts. Lastly, to solve the whole case study, Newton's law of cooling was used to create an equation. So now we will solve the first question, question 8. The question wants to know the cooling equation of the body. So to make it easier, firstly we have to make a table. So there is clock, temperature of the body, and the time in hour. So from the question we can pull out the informations. So for the clock, we don't know when the body was murdered, so we put this question mark. And then the body was first found at 4:30 a.m. and after 2 hours it will be 6:30 a.m. So when the body was first found, we will state it as boundary condition 1, and the other one is boundary condition 2. So for the boundary condition 1, the temperature of the body is 88 degree Fahrenheit, and here is 85.8 degree Fahrenheit. So here is 98.6 degree Fahrenheit. Here is 98.6 degree Fahrenheit because we can assume that it's the initial temperature of the body. And then the time. So for when the murder happened, we put as 0 because we don't know how long has the body has been dead. And here we put T. We put T because we put it as the coefficient. And here is T plus 2. Why it is plus 2? Because after 2 hours. So from here we put as T plus 2. So first we have to state the TO, which is the temperature of the body and the temperature of the surrounding. So for the TO, it is 88 degree Fahrenheit, and for the TS, it is 76 degree Fahrenheit. And then from the equation, A is equals to TO minus TS exponent negative KT plus TS. So we can substitute the value from the table that we made before. So far from the information we get before. So that's the answer for question A. So now for question B. The question asks the value of A. So here we need to show how we get the value of A. In this question we will use Newton's law of cooling. The general formula is dt, here is the temperature of the body, per dt equals to negative K in bracket TO minus TS. From here we will need to bring the TO minus TS here, and this we will bring it here. So it will become dt per TO minus TS equals to negative K dt. Because we already know the value of TO minus TS is equals to 12, so we substitute the value. Okay, and then now we will integrate both sides. So it will be integrate dt per 12 equals to integrate negative K dt. To remove the ln here, we will have to exponent both sides. Yeah. Now we have to apply T O equals to T. We have to apply the condition T0 equals to T0. When the time is equals to 0, the temperature is 0. So we substitute the value of TO and TS. So we will get the value of A is 12. For the last question, which is question C, we will have to find the time of murder and the murderer of the crime. So from the formula, T equals to A x bar negative KT plus TS. So we have to substitute both of the boundary condition 1 and 2. So first we have to substitute boundary condition 1. So when T equals to 88 and time is equals to T, so we write it down here. Then we get 1 equals to x bar negative KT. And then we continue to substitute boundary condition 2. So when T is equals to 85.8, the time is T plus 2. So we substitute all the value from the information, and lastly we will get the value of K is equals to 0.10124. So from there we will have to update T, the equation. So T is equals to 12 exponent negative, because we already know the value of K, so we substitute the value 0.10124 T plus 76. So to determine how long has the body has been murdered, we will substitute the value of the initial temperature of human's body, which is 98.6, because we assume that the initial temperature of human's body is 98.6. So T will come 88.6, and we put all the value here, and we'll solve it, and then we'll get T is equals to negative 6.25 hours. From there, we will have to convert 6.25 hours in hours and minutes. So the decimal number will be multiplied by 60. So we get 50 minutes. So the time of murder was 6 hours and 15 minutes before it was first found at 4:30 a.m. The man. So here we know the man was murdered at 10:15 p.m. To find who the murderer was, to reveal the murderer, we can find it out from the question. So among the 3 suspects, only the business partner does not have an alibi during this time, which is when the murder has happened. So for the conclusion, the business partner was the murderer. For the results and discussion for the case study, I will first explain about the result. So after we solve all of the question in case study N2, we can state that the result was the man was murdered at 10:15 p.m. and the body was found 6 hours and 15 minutes after the murder. The wife and the butler has concrete and enough evidence to prove their innocence, but the business partner does not have an alibi within the murder time. So that concludes that the murder was done by his business partner. For the discussion, to solve this case study, students should also know the application of first order differential equation. The question provided a cooling heating problem, and it was important to use Newton's law of cooling to make an equation. By using separable method, we can use the equation to substitute boundary condition 1 and boundary condition 2 to find the value of A, and substitute boundary condition to find the value of K. After finding both of the value, then we can use it to find the time of murder and to reveal the murderer. That's all from my part. Thank you.